Good morning, everybody. Today we're going to start the first lesson in our last full chapter of the course. Now, that doesn't mean that after this chapter we'll be completely done, but it's definitely going to get us in the right direction. We're going to talk about trigonometry. And trigonometry is actually going to play a role in a whole bunch of your classes in the future. Even pre-calculus, for those of you who are a freshman or sophomore right now and are headed that direction here in a couple of years. So pay attention to the chapter, be ready for it. But before we do anything, back by popular demand, we have Cora.
What do you call a bear that doesn't have teeth? A gummy bear.
All right, once again, Cora did an awesome job. Now, if you're looking at this problem and you're wondering why I have the 5 there, it's because I have had these computer issues and I have made like about 1,000 attempts at trying to get this video to work. And I already started this problem and I forgot to delete it. The good news is, if it seems like you already know how to do this problem, it's because you do. 5 squared plus 12 squared equals c squared. We're going to just use the Pythagorean Theorem because that's what we always do in this situation. And, you know, the Pythagorean Theorem has a ton to do with what we're going to do in this chapter, which is good news because you've been using it all the time. When we talk about trying to find the hypotenuse, it's something you've done a whole lot over and over and over again. This one turns out to be a perfect square, and the answer is 13. So once again, that's good news that we already know a lot about what we're going to be doing here. All right, now example number 2. The reason this one is going to be different is because now the missing side is not the hypotenuse, which means we're going to have to work backwards a little bit. Now, whenever you do the Pythagorean Theorem, A and B are interchangeable. So I could have called the missing side A. I could have called the missing side B. I just was not allowed to call it C. So I'm going to subtract 81 from both sides, and it turns out the missing side length is just 12. So it worked out really, really well. All right, now, example number 3 is one that I'm going to go through pretending that I don't know the answer, even though secretly I do. And honestly, secretly a lot of you might know it as well, because if we were to do 7 squared plus b squared equals 14 squared, this is actually going to kind of turn out to be a waste of our time, depending on how good you were at the previous chapters. Okay, so b squared is 147. It said simplify or round to the nearest tenth. If you were to round it to the nearest tenth, you'd get about 12.1, which is all good, but there's actually a little bit different significance to this that I'm hoping you remember. If you were to take that 147 and you were to try to do the square root of 147, and you were to try to break it down, you would end up breaking it down into a perfect square, and then whatever was left over, and you would get 7 radical 3. Now, when I talk about how before I knew that that was going to happen, I don't know if you noticed this or not, but this was one of our special triangles from before. It's half of an equilateral triangle. We had a side of 7, and then we had a side of 14, and 7 is half of 14. And anytime you have a triangle where the hypotenuse is exactly twice as big as one of the other sides, that means you have a special triangle. So all those rules that we had back in the day, all those little shortcuts about, oh, all I have to do is add in the radical 3 here, we can still remember those, and they will still have some pretty big time value to them. Okay, so I want you to pay close attention to that because everything we did back in the day with the 30, 60, 90 triangle and with the 45, 45, 90 triangle, those things are still going to be around. And in fact, they're going to save us a ton of time if we can remember how to do them. All right, we go to example number 4. Would a triangle with the following sides be acute, right, or obtuse? Now, I'm not even going to lie to you this morning. I feel like we haven't done this before in this class, but it's been so long since I've actually been inside my classroom that we may have done this a while back, and I might just not remember. I don't even know. I just don't even know at this point. So we're just going to go through, and I am going to pretend that you have never seen a problem like this, because I don't think you have. And if I'm wrong, then you know what? You might just learn something anyway. So here's how I want you to set up this problem. I want you to take the little sides, and I want you to put them on the left, and then I want you to put the big side on the right. Now, normally we do the Pythagorean Theorem whenever we're dealing with right triangles. But I look at 7, 8, and 9, and I don't think these are going to be equal. You know, I'm just going to erase this equal sign right here. I just have a feeling this isn't going to work out. What we have here is 49, 64, and then 81. Yeah, 49 and 64 does not equal 81. So then why is it coming out so weird? What is going on here? Well, let me explain. The Pythagorean Theorem only works for right triangles, which means if you take the three numbers that are given and you put them in and it works out to where the left side and the right side are equal, that means it's a right triangle. If you put the three numbers in and they are not equal, then you can use the sign that you have to put in to determine whether or not the triangle you created was acute or obtuse. In this case, you have a 113 and an 81, and 113 is greater than 81. So I am going to summon my memory of back in the day when No, I never really played this. Never mind. Anyway, I hear GTA 6 just came out, something like that. GTA is actually the acronym that I use to remember my rule. And GTA stands for, not Grand Theft Auto, greater than acute. That's the rule. So that's the cheesy rule that I use. If you have a greater than symbol right there, then that means your triangle is actually acute. Okay? And if you drew it out, you'd be able to see 7, 8, and 9 are really close to each other, which means that would actually make pretty close to an equilateral triangle. And equilateral triangles are acute. So it makes sense once you really pause and think about it. But in this case, like I said, the cheesy rule that I'm going to use is GTA. Greater than means acute. All right, let's try this with the next one. We've got 7 squared, 24 squared, and instead of putting an equal sign there, for now I'm just going to put a little blank. I didn't know I could make that symbol. That was pretty cool. 25 squared, there you go. All right, so that would be 49, 576, and 625. So if you add up 49 and 576, you get 625. Wait a second. I have 625 on both sides. That means they're equal. That means it worked. If the formula works, then that means it's a right triangle. That formula was designed to work for right triangles. So if you plug in a squared, b squared, and c squared, and it turns out the left side and the right side are equal, you have a right triangle. Okay, so just to review here, if you have a symbol, I forgot to write the word acute right there. If you have a greater than symbol in between the left side and the right side of your equation, then it's going to be acute. And then we're going to have one that's right. Now, The third example here, 10, 11, and 20, I just want to draw this for you. Hey, do you like that magic? It just popped up there. I want to draw it for you because if you have common sense, a lot of times you can look at the three numbers and right away you'll know the answer. For example, if you look at that red triangle that I just drew, you pretty much know that it's going to be obtuse. That angle right there is definitely an obtuse angle. So I'm going to just throw that out there as something to think about as you're going through this math right here. 10 squared, 11 squared, and 20 squared. So you've got 100 and 121, and then 400. And when I look, I would say 221 is definitely going to be less than 400. So if the two numbers come out and you have a greater than symbol, it means acute. If they come out equal, it's right, so that means less than. There's really only one option left, and that would be obtuse. Not only that, if we're doing examples together, there was a good chance that I was going to make you one example out of each type anyway. So that's just the way it's going to work. All right, our last example of the day is actually something that I've been teaching you to do all year. Some teachers don't. I generally do. Those of you who know me well, you know that me and the distance formula are definitely fighting. If you give me 2 points and you tell me to find the distance between the points, I do not use the distance formula. It's never really been a thing. I never learned it until I was maybe like 21 years old or something like that. It was pretty ridiculous. So I bring that up because for some people this is going to be a new topic, but for you, I don't think it's going to be. Demonstrate the distance from 0, 0 to 6, 3 by sketching a triangle and using the Pythagorean theorem. Well, we just talked about this. The Pythagorean theorem only works for right triangles, which means if you are going to sketch a triangle and count the squares so that you can use the Pythagorean theorem, you would have to sketch a right triangle. So then you would do 3 squared plus 6 squared equals c squared. And you would end up getting 45. Now, from here, you have two options. You can either round to the nearest tenth, or you could simplify a radical. Because remember, if we want to actually solve for c, we would have to take the square root of both sides. Okay. So if you were to simplify the radical, if you were to take 45 and you were to simplify the radical, you would end up getting 9 times 5. And then the reason I chose 9 is because the square root of 9 is 3. There you go. So you get 3 radical 5. I'm also giving you the option of using decimals rounded to the nearest tenth if you are struggling with simplifying radicals. And I got 6.7 for that. So you've got 6.7 or 3 radical 5. All right, now because we are in sort of a different situation, we're going to go through the second section, and we are going to go through just a few more together. And I'm going to leave you with 5 to do on your own. So you're going to do 8, 10, 12, 14, and 16 on your own. And we're going to do just a few more odd-numbered problems together just to make sure you know what's going on. So we're going to practice just a little bit more here. So for number 9, if you're ever curious, based on the drawing being kind of weird, if you're ever curious as to where the hypotenuse is, it's always going to be opposite the right angle. So all you have to do to figure it out is just take the side farthest away from the right angle and mark that down. I just made a music note. Huh. Boy, you learn something new every day. All right, there you go. 9 squared plus 40 squared equals c squared. Now, I don't know if you're the type who gets a number that big and you think you've done something wrong. Turns out you didn't. And everything was just fine. The answer there was 41. Because if you were to do the square root of both sides, you would get the square root of 1681, which is actually a perfect square, even though you might not have known it. All right, we got just a few more here. We're going to do 11, 13, and 15. And then we wrap up, and I'll have you do those other 5, like I said. So for number 11, remember, the missing side is not the hypotenuse. So you can call the missing side A, you can call it B. Just whatever you do, do not call it C. Now in this case, if these numbers look like they keep coming up, you know, like a 576, a 625, Pythagorean triples always work. Like 3, 4, 5 always works. So we always want to sort of be in tune to those numbers. That way maybe we can save ourselves time down the way. It turns out the missing side is actually just 7. You know, those numbers looked like they were going to come out kind of funky. Turned out they didn't. The answer was just going to be 7. All right, number 13. If you remember that this number is twice as big as this number, then that means you don't have to do any math right here because you can do the shortcut. Now, meanwhile, if you don't know that math and you have to go through the long way, it's too bad for you, but I guess we'll live. We'll have to do it this way. All right, so that's going to give you 10,000 plus b squared equals 40,000. Okay, this is not going to go well. What are we going to do? Well, it's actually not as bad as you think it's going to be. If you were to do the square root of 30,000, you would end up getting 173.2. Or, if you were to do the simplified radical, it would actually turn out to be a pretty easy one. The reason being 30,000 is really just 10,000 times 3. And the square root of 10,000 is 100. So you really have 100 times the square root of 3. Which then brings me back to that shortcut. Remember, I was saying if you knew what was going on, if you recognized the shortcut, then you wouldn't have to do any math because you would already know what was coming. And what was coming was the radical 3 shortcut. Okay, so that means you could have put one of 2 answers here. Even though the radical is ugly, it does save you time, so I would encourage you to get good at that shortcut. And in case you forgot again, that is the shortcut that works for 30, 60, 90 triangles. The reason it works is because it is half of an equilateral triangle. So if I told you that was 8, and that was 4, and that was a right angle, then that means it's really just half of an equilateral triangle. And the shortcut is that the missing side would be 4 radical 3. We did that a whole bunch in the past. Hopefully now you still remember, and if not, we'll practice it more and we'll make sure you get it down. All right, the last problem of the day, the last one I want to do is actually number 15, because there are 2 missing sides. And so a lot of people look at that and they think it's not going to go well, or they just think it's impossible altogether because they see 2 missing sides. So I would encourage you to just start the problem and just see, because you might realize it's not as impossible as you think. Now, the key to this problem is that you have to square the 3 and make it 9, and you have to square the x. So you end up getting something that looks like that. Now the reason it works that way is because the 3x is in parentheses. That means everything inside the parentheses gets squared. And then x squared plus 9x squared equals 10x squared. And then if you were to divide both sides by 10, this is that last step that people might not be expecting because it hasn't come up yet today. You have 10x squared equals 900, which means x squared equals 90. And again, I will accept any of two different answers here. If you were to take the square root of both sides, the biggest perfect square that goes into 90 is 9. So you would get either 3 radical 10. That would be the simplified radical. Or if you were to just try and simplify on your calculator, you would get 9.5 if you just did the nearest 10. Either way, I would take it. I do think it's important that we practice simplifying radicals, but I will take it either way for now. Okay, so this is one of those weird problems. Don't overreact to the fact that you have two missing sides. You're just going to have to combine your like terms and then work with it a little bit differently. So like number 14, don't overreact to the fact that there are two missing sides. In fact, they're both the same because they're both marked that way, so it wouldn't really be a big deal anyway. So anyway, I hope this gets you started with the lesson. You've got 5 questions to do, remember. I need you to work on 8, 10, 12, 14, and 16. Those will be the 5 that I check. Do your best. Take care of yourselves, take care of each other, and I will see you next time.